T2 and L1. So T2L1, Topic 2, Lesson 1. And that's continued from the other page. And if you don't want to write out the word continued, you can abbreviate. I'm going to turn the page over one more time for a second. On the bottom of this page, why don't we put an arrow? So we know that there's more on the next page. Now let's flip back over. Pause anytime. If I'm going too fast, you can pause the video to get caught up or go back and watch something again. So a sequence can be infinite or finite. I'm going to color code these. So I'm going to make everything infinite green, and everything finite is going to be pink. So infinite means that it continues on forever. Finite means that it terminates or ends. And let's look at a specific example of each one of those. And I'm going to make a connection to the work you've already done in your textbook. So an infinite sequence can be found on page M190 in your textbook, number 2. That's an infinite one, and it's about the family tree. So we started out with Jessica. There's Jessica, and then she has 2 parents. And each one of those parents has 2 parents. And each one of those parents has 2 parents. And we can see that we could continue on forever doing this. This is infinite. My hand might not be able to, but the generations can. Okay, so each one of these represents a generation. We're going to call this one here our first generation. And we're going to put this information in a table. So we're going to start with our term number, which is the number of generations. I'm going to put a pound symbol instead of writing out the word number. So number of generations. That's our term number. And then the number of parents is our term value. So again, we always start with 1, 2, 3, 4, and 5. So our first generation had 2 parents. Our second generation had 4 parents. Our third generation had 8 parents. Now I can see a pattern here. We're doubling each time, so I know then the next one's going to be 16, and the 5th generation has 32. And to show that this is going on forever, I put 3 dots. So I'm writing this means it continues on forever. So as soon as you see those three dots at the end of a sequence, you know that you have an infinite sequence. Now, if you don't see the dots, then you need to look at the situation and decide whether it's infinite or finite. So a finite sequence is next. We're going to match that with our pink up here. So just going to write finite sequence. And we're going to find an example of that on the same page, page M190, example number 9. And that one is finite. And it's called a collection of squares. So I'm going to draw my squares down here. So I am not going to start with the first sequence because in the book, because that one has 49 squares. So I'm going to start with the fourth term in that sequence because it only has 16 squares, and I can draw that pretty easily here. Notice here I'm using 2 lines so that it makes it really easy to split this up into 4 parts vertically and 4 parts horizontally. Okay. So this is the fourth term. And then the next one was a 3 by 3. So I'm going to go thinking like 9 squares. So it needs to look about like this. So I'm going to do thirds. My pen is dying. To switch colors here. So there's 9 squares. 3 by 3 makes 9 squares. And then I'm going to do another one that has, it's a 2 by 2, 4 squares, and our last one is just 1 square all by itself. So I can see I can't get any less than 1 square. That's what makes it finite. So this is the 5th term. This is the 6th term. And this was the 7th term. You can see that in the textbook. But in my table of values here, I'm going to put all of the terms. So I have my term number and my term value. And the term value is the number of squares. Starting at 1, 2, 3, 4. There's our 4 right here. 5, 6, 7. So our first term in the textbook had 49 squares. It was a 7 by 7 square. And then 36, 25, and then starting here, the ones that we can see, there's our 16 squares. 9 squares is our next one, our 5th term. 4 squares, and then 1 square. So I'm just going to write down here that the sequence is finite because it has to end. And that's what I mean by looking at the problem situation to decide whether it's finite or infinite, if the 3 dots aren't there. I'm going to say there can't be less than 1 square. Slide that up just a little bit. And that is it for the notes. Thank you all for following along.